Hello everyone, welcome to Brain Blitz Audios. Today in this episode of NEET preparation, we'll be looking at previous year questions of physics in medical entrance examinations in India. Today we're going to be dealing with motion in a plane. This is the third chapter in the grade 11 syllabus for physics in CBSE. Now let's look at our first question. Two vectors having equal magnitudes of x units acts at an angle of 45 degrees, and they have their resultant as 2 plus root 2 the whole root units. We need to find the value of x. So how do we solve this question? Now in this question we have two vectors having equal magnitude x. So vector p is equal to vector q is equal to x units. And the angle between them, theta, is 45 degrees. So you have P, you have Q, and the angle between them is 45 degrees. And then you have a resultant, which is present in between them, R, that is equal to 2 plus root 2, the whole root units. We need to find the value of x. Now, what is the resultant of two vectors? The formula for resultant of two vectors is r equals p square plus q square plus 2pq cos theta. Now, over here, we'll substitute r as 2 plus root 2 the whole root. And on the left-hand side, we'll substitute p equals q equals x and cos theta as cos 45. So x squared plus 2 times x times cos 45. That will be equal to 2x squared plus 2x squared times 1 by root 2. All of that under a root. So therefore, you'll get 2x squared plus root 2 x squared. This is the equation that we get. On squaring, you'll get 2 plus root 2 equals 2x squared plus root 2 x squared. We'll take x squared common, so the value inside the bracket will be 2 plus root 2. Therefore, x squared will be equal to 2 plus root 2 divided by 2 plus root 2. Both the values are the same, so you get 1. When x squared equals 1, the value of x is equal to 1. So therefore, the right answer is option B, 1. And we used the formula for the resultant of two vectors. Let's look at question number 2. If R and H represent the horizontal range and the maximum height achieved by a projectile, then which of these relations is correct? H by R is 4 cot theta, R by H is 4 cot theta, H by R is 4 tan theta, R by H is 4 tan theta. So over here we need to use the formula. The formula for horizontal range is u squared sine 2 theta divided by g, which we can write as u squared times 2 sine theta cos theta divided by g. Maximum height can be written down as u squared sine square theta divided by 2g. First, let's divide h by r. That will be u squared sine square theta divided by 2g, the whole divided by 2u squared sine theta cos theta divided by g. Therefore, h by r is equal to u squared sine square theta divided by 2g times g divided by u squared times 2 sine theta cos theta. So you can cancel out one of the sine thetas, you can cancel out u squared, and you can cancel out g. So h by r equals sine theta divided by 2 times 2 is 4, and cos theta. Sine theta divided by 4 cos theta is h divided by r. Let's take the inverse. So therefore, r divided by h will be 4 cos theta divided by sine theta. And therefore, you can write cos theta by sine theta as cot theta. So the right option is option B. R by h is equal to 4 cot theta. It's important to keep the 4 in the numerator, otherwise you cannot form it in terms of cot or tan theta. And that's why we took the inverse of the earlier relation. So here h by r is what we found out to be sine theta by 4 cos theta. So therefore, we took the inverse, that is r by h, in order to get 4 cot theta. Let's look at this question. The acceleration of a body in a non-uniform circular motion is 5 meters per second square. Which of the following is correct? The radial acceleration and the tangential accelerations are A 3 and 4 meters per second square, B 2 and 3 meters per second square, C 5 meters per second square both, D 5 and 3 meters per second square respectively. So in order to solve this question, it's important to note that the acceleration of a body in the non-uniform circular motion will be the resultant of radial and tangential acceleration. Now, if we take option A, 3 meters per second square and 4 meters per second square, then the acceleration will be equal to the resultant, that is 3 square plus 4 square, the whole root, 9 plus 16, the whole root of 25, which is equal to 5. So therefore, option A is the correct option. The acceleration of a body will become 5 meters per second square if its radial acceleration is 3 meters per second square and the tangential acceleration is 4 meters per second square. If you look at option B, the answer that you'll get is root 13, which is not equal to 5. In option C, you get 5 root 2 as the resultant, which is also incorrect. In option D, you get root 34, which is also incorrect. The right answer is option A. The radial acceleration is 3 meters per second square and the tangential acceleration is 4 meters per second square. Next question. An aircraft executes a horizontal loop with a speed of 150 meters per second with its wings banked at an angle of 12 degrees. The radius of the loop given is, we have tan 12 is 0.2125 and acceleration due to gravity is 10 meters per second square. We need to find the radius of the loop, and for that we use the formula tan theta is equal to v squared by rg. So in this case, the wings are banked at an angle of 12 degrees. So therefore, tan theta will be equal to tan 12. And if you want to look at the velocity, the speed here is given as 150 meters per second. So v squared will be 150 the whole square, divided by, the radius is unknown, so that's r. G is 10 meters per second square. So we can write tan 12 as 150 times 150 divided by 10r. You can cancel out a 10. So you have 150 times 15 in the numerator. That is equal to 2250 divided by r. in the right hand side, and in the left hand side you have tan 12. So therefore you can find out r, and the value of r will be 2250 divided by tan 12. So that will be 2250 divided by the value of tan 12 is 0.2125. What we're going to do is we're going to multiply by 10 raised to 4 on both the numerator and the denominator. So you'll get 2250 times 10 raised to 4 divided by 2125. So now we're going to divide 2250 divided by 2125. 2125 times 1 is 2125. If you take 2 times 2125, that will be greater than 2250. So I'll write 1. 2125. 10 minus 5 is 5. 4 minus 2 is 2. 2 minus 1 is 1. And 0. So 125 does not have any number of 2125s present. So we put a dot. So you'll get a 0, but it's still short. So you'll write another 0. So 12500. If you take 2125 times 5, you get 25. 10 plus 2 is 12. 5 plus 1 is 6. 25, 10. So 10625. So that'll be 5 here. So this will go on forever, but let's take 1.05 as our answer for now. So therefore v will be equal to 1.05 into 10 raised to 4. I mean, this is not v, this is r. The radius will be 1.05 into 10 raised to 4 meters. 1.05 into 10 raised to 4 can be written down as 10.5 into 10 raised to 3 meters. 10 raised to 3 meters is equal to 1 kilometer, so that means 10.5 kilometers will be the radius, which is approximately equal to 10.6 kilometers. And the reason why we made that approximation is because option A, 10.6 kilometers, is the closest option, so it is the right answer. So option A, 10.6 kilometers, is the radius of the horizontal loop made by the aeroplane. Let's look at the final question for this episode. For ordinary terrestrial experiments, the observer in an inertial frame in the following cases is. So we have 4 cases here. We need to find out which of these is present in an inertial frame. So for it to be in an inertial frame, there should be no acceleration on the observer. The observer should not experience any acceleration. If it experiences acceleration, then it is a non-inertial frame of reference. Now, let's look at the first option. A child revolving in a giant wheel. A giant wheel represents vertical circular motion. And in vertical circular motion, you always have non-uniform velocity, so there is always an acceleration. You have radial acceleration and tangential acceleration acting on a giant wheel. So option A is incorrect. Now, what about option C, the pilot of an aeroplane which is taking off? Now, the pilot of an aeroplane taking off experiences a change in direction. And in case of an aeroplane, there's also the change in velocity as well. In option D, a cyclist negotiating a sharp curve, you also have the same scenario, which is a change in direction. So therefore, option C and D are incorrect. The right answer is option B. A driver in a sports car moving with a constant high speed of 200 kilometers per hour on a straight road. Over here, you can see constant high speed of 200 kilometers per hour, and the direction is also stable because it's a straight road. So therefore, option B is the right option for labeling the observer in an inertial frame of reference. So that concludes this episode. We hope you found it interesting. For more of our earlier videos regarding motion in a plane, you can always go back to our playlist in the description down below. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. So until the next webisode, take care, stay safe, bye-bye for now.